Greetings to all the viewers. Now we are going to conduct the session based on the organic chemistry. The session what we are covering is powered by AI powered session it will be, and the topic chosen for the day will be oxidation using oxygen. The topic, the in the broader sense, this is the kind of oxidation reductions. In that oxidation reductions, every day we are going to handle the individual reagent. Based on that reagent, what kind of applications we can find, that is the way we are going to conduct the sessions. Today's session is resided with oxidation using oxygen. How oxygen working like a oxidizing agent, that is the topic chosen for the day. Oxidations and reduction reactions is the broader concept. In that, the individual concept will be oxidizing agent, that is oxygen. Combination of oxygen or loss of electrons is said to be oxidation process. Whenever we are going to treat magnesium metal with this oxygen molecule, so that formation of magnesium oxide is possible. In both the ways, we can say it is the kind of oxidation. In the context of oxygen, addition of oxygen is said to be oxidation process. In the context of electron transfer, here, loss of electrons is said to be oxidation. Magnesium initially at a zero oxidation state. After the reaction with oxygen, it turned into dipositive. Two positive charges are indicated on the magnesium head. That's the reason why increasing the oxidation state, that is the because of transfer of electrons is also said to be oxidation. That's the reason why magnesium is subjected to oxidation by combining with oxygen molecule. This is the simplest example corresponding to oxygen working like a oxidizing agent. Here is the molecular oxygen provided. Always oxygen is a diatomic in nature, and both the oxygen atoms are bonded with the double bond. This is in correspondence with the molecular orbital theory. There is a existence of double bond in between two atomic oxygens, and this oxygen molecule is paramagnetic in nature in terms of its magnetic behavior. And this is another example. Again, the metallic sodium is able to combine with the oxygen molecule, so that sodium oxide is the product. Again, with respect to sodium, it is the oxidation reaction, and oxygen is the oxidizing agent. This is the way the reactions are provided in a glance. Let's enter into the topic what we chosen. Oxidation reactions with oxygen is a chemical process where the substance react with the molecular oxygen. Here, the molecular oxygen is taken as an oxidizing agent. These reactions are typically leads to the loss of electrons from the reacting species and are crucial in a various natural and industrial process. Below are some common categories and the examples pertaining to this kind of oxidation reaction with oxygen. If you observe, magnesium, here is the magnesium, sorry, let me include the sound. Okay. Magnesium is the metal. Upon reacting with oxygen, there is a formation of magnesium oxide where magnesium is oxidized and oxygen is used to be reduced. Always, oxidation reaction simultaneously carried out in addition to reduction process. Both the reactions are simultaneous in nature, and together both are treated as a redox reactions. Okay. Always metals having natural tendency to lose the electron, so that here positive dipositive magnesium will be obtained. Whatever electrons released by the magnesium accepted by the oxygen, so that oxide formation is possible. Gain of electrons are carried by the oxygen. Ultimately, there is a formation of magnesium oxide. Here you can observe, whenever oxygen is in a molecular oxygen form, there is a resultant charge is zero. And whenever you have hydrogen peroxide, always peroxide oxygen is accommodated by -1 oxidation state. Whenever fluorine dioxide is the case, that depends upon electronegativity difference. In comparison to the fluorine, oxygen is more electropositive, because the fluorine is the highest electronegative element in the entire periodic table. With respect to fluorine, oxygen is becoming electropositive forcibly, so that here you can observe dipositive charge on the oxygen. This is the way, though it is this individual oxygen only, with respect to the adjacent atom, its oxidation states got varied. Molecular oxygen with the zero, and hydrogen peroxide with the negative one. Dihydrogen difluoride will be dipositive charge over the oxygen. This is the way you can categorize oxygen. There is a possibility of +2, +1, 0, -1, -2. These many possibilities are there. Oxidation states all corresponds to oxygen atom, right? This is the way oxidation reactions are possible. Now we entered into examples which are related with the oxidation with oxygen. Let's go with the natural combustion process. Combustion is defined as a rapid reaction of the substance with the oxygen releasing energy in the form of either heat or light. Any substance you are taking with that to be ignited, whenever you are igniting that substance, that ignition, that burning process carried in the presence of oxygen, and during that burning process, it used to evolve the huge amount of heat or else light, right? This is the way combustion is carried. The simplest example is burning of coal. Whenever coal subjected to burning, lot of heat will be evolved, that is the thermal energy. This is the simplest example for the combustion process. Let me show the examples pertaining with the combustion. Hydrocarbons may be taken. Let me take petrol for example. So petrol is the kind of hydrocarbon only. You may combine with oxygen. There is a process of combustion that is giving rise to carbon upon oxidation giving carbon dioxide. Hydrogen upon oxidation gives water as the products. Along with these combustion products, there is a lot of heat evolved in the form of energy, right? So that energy evolved used to run the vehicle, so that there is a transportation with respect to that, either petrol, diesel, CNG, whatever hydrocarbons, all hydrocarbons, all the fuels, fossil fuels, whatever we are consuming are the part of hydrocarbons only. They subjected to the process of combustion, so that energy will be evolved. Internal combustion we can notice. Here the natural gas was taken, where the component will be methane. Methane upon combustion giving rise to carbon dioxide, or by the combustion of carbon, and hydrogen will be combusted giving water as the product. In addition, there is a huge amount of energy evolved. So natural gas is the kind of CNG, compressed natural gas is available. Or else you may go with the where we can use in automobile fuel. You can consume this one, or else domestic fuel is CNG is also the kind of cooking fuel. So in this manner, there is a kind of combustion giving rise to energy can be applied in the industrial, automobile, even household purpose, right? Complete balanced equation is provided for our better understanding. You can notice methane subjected to reaction with 2 moles of oxygen giving rise to a carbon dioxide and 2 moles of water, in addition of lot of energy. So being it is the kind of energy evaluation, you can say exothermic in nature. Heat evolved during the reaction is called exothermic, right? So there is the formation. If combustion is not sufficient, that means whatever the kind of methane is there, that extent oxygen is not available. Insufficient oxygen supply giving rise to mixture of products. There is a partial combustion we can notice. Carbon may convert it into carbon monoxide and carbon dioxide as well, in addition to another byproduct called water. So that carbon monoxide, carbon dioxide mixture is available whenever combustion is not sufficient, where oxygen availability is not sufficient. In insufficient combustion is carried. This is the case which occurs in some condition. Trace amount of carbon monoxide is also originated. So here is the complete description. You can notice the blue flame corresponding to the burning of natural gas over there. That is of methane. So measure content in that natural gas will be a methane only, which able to provide upon combustion giving rise to the heat is existed in the form of blue color flame. Here is the carbon accompanied by the four hydrogens in the tetrahedral geometry, and you're going to bind up with the biatomic oxygen molecule over there, and there is a formation of a linear molecule, that is a carbon double bond O carbon dioxide we can notice. And here is the water with respect to this red color lobe indicates a high what we can say oxygen, and these two blue lobes are hydrogens. There is a provision for 2 moles of water, so the two water molecules are mentioned over. This is the entire diagrammatic representation for the better understanding for this combustion process. Hydrocarbons upon combustion giving carbon dioxide, water as the combustion products, in addition to the lot of energy generation. Let's go with another natural phenomenon with respect to the oxygen oxidation process, rusting, which is in turn called as a corrosion, right? Any kind of, most of the metallic devices, not all, I'm not mentioning all metallic devices. Most of the metallic devices are made by iron, or else it's alloy forms only. You may take any kind of industrial machinery, or else transportation devices, industrial containers, and household devices. In most of the cases, not all the products I'm mentioning, most of the products are made by iron and its alloys only. Worldwide, 60 percentage of metallic usage resided with the iron and its alloy forms only. That's the reason why rusting is the a kind of a great hassle in terms of that loss of metal by the natural process of corrosion, right? So that is the process carried whenever iron is in direct contact with oxygen and in addition to the moisture. Both are important essential components for rusting of iron, so that iron is transformed into its hydroxide form. Later on oxidation giving rise to a ferric oxide, ferric oxide will be originated. This ferric oxide dihydrate is said to be what? Rust. There is a provision for rusting if that metal is not properly protected. Whenever metal extracted, after the extraction, that is subjected to the fabrication into various kind of machinery, or else any kind of wire, sheet, tube, whatever the kind of we need. Right. Before making into the required dimension, that metal should be properly protected. Then only we can avoid the process called rusting. So rusting is the process accompanied by this metallic materials. In specific, iron is subjected to that rusting whenever it is in contact with water in addition to the oxygen molecule. It is the kind of oxidizing agent. Corrosion is the process of oxidation, so that that metal will be totally rusted over there. So iron, upon reacting with water and oxygen, giving rise to a hydrated ferric oxide. So this is the natural phenomenon. It is a kind of deterioration of metal, so that metallic properties are vanished by this natural oxidation process. In order to avoid this, the metal should be properly protected by means of either galvanization, tinning, electroplating, electroless plating, metal cladding, metal spraying, or else organic paints are available. So many kind of protecting methods are available nowadays, so that we can avoid the process called corrosion in order to protect that metal. Let's go with another process called auto-oxidation. Auto-oxidation defined as whenever a metal, whenever any kind of substance is direct contact with air. Air is the combination of gases only, right? So air is nothing but mixture of gases. Among all, around 70% nitrogen is present, and 20 to 23 percentage of oxygen is mixed up with the air, and traces of carbon dioxide and minute quantity of noble gases also the part of that atmosphere, right? So whenever any substance is in the open dish, So let me pour this aldehyde in the open dish. After some time, so whenever time passes, what happens? Slowly this aldehyde is transformed into this carboxylic acid. We are not mixing up with any kind of reagent from the external source. Though it is the kind of natural, though it is the kind, this is the material present in the open dish, without addition of any material, there is a provision for the conversion of this aldehyde into carboxylic acid. That is because that is in direct contact with the air. From that air, there is a provision to mix it with oxygen without any addition. Itself, it is going to mix up with this aldehyde, giving rise to the higher level oxidized product called carboxylic acid. This is said to be what? Auto-oxidation. Auto-oxidation is defined as any process which is carried itself without any involvement of either enzymes, catalyst, reagent, anything we are not supposed to add. Rather itself, it is the kind of it is the kind of natural process which is said to be a auto-oxidation. That is clearly mentioned, aldehyde taken in the open dish, and after few minutes, after some time, it blended with the air. From that air, oxygen is mixed up so that carboxylic acid will be generated. Here is the clear description for that kind of process, whatever carried by the oxygen addition giving rise to the oxidized products. So many reactions are mentioned for better understanding of auto-oxidation process. Let's go with the next process by means of addition of oxygen as the oxidizing agent. That is the natural process again called a cellular respiration, right? Definition of cellular respiration: biochemical oxidation of glucose. Glucose, where glucose is generated by the natural process of plant, which is called a photosynthesis. Photosynthesis is used to generate the food material. That's why we can say they are autotrophs. So they are producing self food producing materials, right? So that plants are able to generate the glucose and its related food products. Those food products through the dietary ingredients, they may transport it from one species to another species in the different trophic levels, and the different organisms are able to consume that kind of carbohydrate matter which generated by the plant. So, whenever we are consuming that kind of glucose, for example, whenever we ate our food per the day, right? So that carbohydrate entered inside, that able to generate the energy in the living organisms by the process called biochemical oxidation. Biochemical oxidation is carried upon the carbohydrate what we are consuming, so that that able to convert into a form called energy. That energy can be utilized for all our activities, whatever we are working in our daily routine. So all energy can be generated by means of biochemical oxidation of food what we are consuming. In order to make into this food into energy, there is a requirement is oxygen again. That is the natural process said to be cellular respiration, right? So if we are taking glucose as a simpler carbohydrate what we are consuming, either rice or wheat in our consideration, at that condition C6H12O6 is the carbohydrate, glucose we can denote, and oxygen is the oxidizing agent over here, so that it may break down the entire complex molecule of this carbohydrate and giving rise to a simpler molecules called a combustion. Simply said to be a combustion process, the carbon entirely converted into oxidized product called carbon dioxide. Hydrogen corresponds to water as the product, and in addition to all this, there is a huge amount of energy originated over there, that is in the form of adenosine triphosphate. Adenosine triphosphate is a kind of energy generated inside our body. For example, if you are not consuming food for longer time, for one day we are not having any food intake is zero. At that instance, our body will experience loss of energy. Why we are not getting energy? Fuel is not there, our fuel is not given for the day. That's the reason why whenever we are consuming carbohydrate continuously, this is the process carried called biochemical oxidation. Continuously energy generation is possible in the form of ATP, adenosine triphosphate, so that so that this energy is the requirement for all our daily activities. The powerhouse of all the living organisms are said to be mitochondria. In that mitochondria only there is a kind of food, and food can be oxidized, giving rise to the energy in the form of ATP, so that we can say mitochondria is the powerhouse of that living organism. This is the way cellular respiration is the natural phenomenon for this oxidation with oxygen. Going to the catalytic oxidation, so many catalyte driven oxidation process also possible in order to achieve the required product. Definition for catalytic oxidation: oxidation reactions facilitated by the catalyst. So if we are adding any catalyst that used to enhance the rate of reaction in order to make the reaction in the shorter time. Oxidation of ammonia in the Oswald process for the nitric acid production. Ammonia is a kind of hydrogenated product, right? Whenever this ammonia is added with this oxygen, so oxygen can be blended up in the presence of either platinum or the rhodium catalyst, or transition metal catalysts only. Whenever the oxidation carried in the presence of metal catalyst, the rate of reaction will be enhanced by many folds, so that corresponding hydride of nitrogen will be converted into oxide of nitrogen. NO is said to be nitric oxide. The method carried is called Oswald process, and here the catalyst applied will be either platinum or the rhodium catalyst, so that ammonia will be transformed into nitric oxide in addition to the water as the byproduct. This is the way oxidation with oxygen is possible. Let's go with another another simpler example pertaining with oxygen as the oxidizing agent. Combustion of carbon monoxide. Carbon monoxide is said to be what? Partially oxidized form of the carbon only, but it is not the higher extent. This is not the maximum limit. It is the oxidized form of the carbon only, but still there is a provision to oxidize in the next step. Whenever carbon monoxide is added with oxygen, so that that will be completely oxidized, giving rise to carbon dioxide. Carbon dioxide is the maximum saturation level for the carbon in order to make the highest oxidized form. This is the way carbon dioxide will be generated. Whenever we observe the levels of carbon dioxide and carbon monoxide in our environment, carbon monoxide is a critical indicator of the pollution in comparison to the carbon dioxide. Why we are saying, why both are, though both are the oxides of carbon only, but carbon monoxide is somewhat hazardous in comparison to the carbon dioxide. Carbon dioxide sometimes may not be considered as a pollutant. The reason behind that will be carbon dioxide is the very important ingredient for the food production by the process called photosynthesis. That's why carbon dioxide levels will be maintained by means of plantation. So that though we are having higher level of carbon dioxide, sometimes we are not supposed to treat carbon dioxide as a pollutant. That is because it is the starting material for the food production what we are consuming. That is one case. And hazardous nature of carbon dioxide in comparison to carbon monoxide is less. Whenever inhaled inside, that is not generating that extent of hassle in the human organs. Two reasons we have. And let's go with the impact of carbon monoxide on and the consumption, right? Well, for example, we are consuming carbon monoxide inside our body in addition to the oxygen. That carbon monoxide may bounded with the blood inside our body. The important thing is a blood circulation process which is altered by the lung system, that is called respiratory, and also that cardiovascular system, that is heart and its related veins, right? So whenever we are inhaling carbonated air, that means carbon monoxide concentration is higher in the air. That carbon monoxide whenever entered inside, that can bind up with the blood. Whenever carbon monoxide bonded with the blood, that having stronger affinity towards the heme means what? Iron is present in that. It is a kind of protein. globular protein we have, that heme is having higher affinity to bind up with the carbon monoxide, so that the bondage will be higher, so that it will not detach from that blood. It will be carboxy hemoglobin will be generated. Once it is generated, whenever that blood is circulating the entire body, there is a provision to carry the oxygen and release at the particular organ, and carrying back that carbon dioxide. Entire duty of that blood totally lost. There is a insufficiency in the circulation of oxygen whenever carbonated blood is generated inside. That is generating the severe anemia in the people who are inhaling this carbonated air inside. That's the reason why we can say the severity of symptoms whenever carbon monoxide inhaled inside will be acute in comparison to the carbon monoxide. This is the reason why carbon monoxide to be oxidized completely by mixing up with the oxygen, so that carbon monoxide turned into carbon dioxide over there. This is another combustion process only, right? Carbon monoxide will be a kind of triple bonded molecule between carbon and oxygen, can be blended with the oxygen molecule, and there is a provision for the formation of molecular carbon dioxide. Right, so this is the way we can generate carbon dioxide somewhat safer in comparison to the carbon monoxide. And next is about photooxidation. Photooxidation stands for what? Photo means what? Sunlight is induced for the oxidation process, right? Oxidation initiated by the absorption of light. Whenever sunlight is irradiated upon the reaction mixture, that process is said to be photoirradiated reaction. Photocatalyzed reactions we can define. Oxidation initiated by the absorption of the light, right? Whenever any reaction is facilitated by means of irradiation with the sunlight, so that reaction is regarded as a photooxidation, right? Oxidation of pollutants in advanced oxidation process, right? Whenever some kind of pollutants are there in the environment, we are supposed to destroy those pollutants from the environment. We need to clean up the air. At that instant, directly the pollutants are subjected to air. In that air, we have oxygen molecules. In addition, sufficient penetration of sunlight is also requirement. In the presence of sunlight, oxygen will be added to that kind of pollutant, so that there is enhanced rate of reaction. Oxidation will be carried, and whatever pollutant is there, that will be subjected to oxidation process, and finally that will be transformed into a non-pollutant system. This is said to be a kind of detoxification by means of photooxidation. This is purely environmentally benign process, we can say. Whatever nitrogen oxides are present, upon oxidation, they converted into higher oxide forms, like nitrates will be generated. The formed products may not be a kind of pollutant, so that we can say photooxidation is a purely environmentally benign, used to remove the pollutant from the environment by means of oxidation in the presence of sunlight. Oxidation of sulfur compounds. So everybody aware that sulfur and their acids. Sulfuric acid is the kind of material which is having a wide range of applications. It is a versatile mineral acid, and it is the strongest acid in inorganic or else mineral acids, that can be synthesized by the process called the contact process. In order to manufacture that sulfuric acid, initially we are taking the starting material, that is sulfur dioxide. Sulfur dioxide is not the maximum level of saturation of its oxidation environment. That's the reason why the sulfur dioxide further subjected with the reaction with oxygen molecule. This is a kind of oxidation we can denote. The sulfur dioxide now reacted with oxygen in the presence of catalyst. The catalyst applied here, vanadium pentoxide. V2O5, again it is the transition metal oxide only. Vanadium pentoxide is blended with this reaction mixture in order to enhance the rate of reaction, so that sulfur dioxide now transformed into sulfur trioxide. There is a formation of higher oxidation level for this sulfur. right? So this is the way the oxidation carried by the catalytic oxidation process of sulfur dioxide in order to obtain this sulfur trioxide. This is carried in a contact process. Further, this sulfur trioxide will be hydrolyzed in order to achieve that sulfuric acid. This is the way oxidation of sulfur is a requirement in a contact process in order to convert sulfur dioxide into sulfur trioxide. This is also the kind of application of oxygen induced oxidation. Now we entered into another segment where you can observe. This is the kind of observation, key features of oxidation reactions which are involving oxygen as the oxidizing agent. Whenever oxygen embedded, oxygen added oxidations are carried, always, oftenly they are said to be exothermic in nature. While oxidation process, the huge amount of heat is evolved. Just now we observed whenever we are burning that coal or else burning the fossil fuels like a wood. Simply we can say wood is subjected to combustion process, so that there is a generation of heat energy. Everybody notice that, right? So that we can generalize the process. Oftenly they are said to be exothermic in nature and releasing lot amount of energy. Common criteria for this oxidation by means of oxygen lead to the formation of oxides. So whatever, for example, tin is added with oxygen, there is a formation of tin oxide. That's the reason why any metal oxide you're concerning, non-metal oxide are also the condition. There is a provision for their corresponding oxides, either metal oxides or else non-metal, irrespective of the nature of that material binded up with oxygen. There is a formation of oxides are possible. Metals when treated, metal oxides, non-metals giving rise to non-metal oxides, right? Tin blended with oxygen giving rise to tin dioxide, and silicon give upon oxidation with oxygen giving rise to silicon dioxide. Titanium binded up with oxygen gas, so that titanium dioxide will be generated. All these are said to be metals. Corresponding metal oxides are originated. Let's observe non-metal oxides. Sulfur is a non-metal. It is a kind of solid. Everybody aware it is a hexagonal. That AC8 molecular form is available for the sulfur. This sulfur is blended up with the oxygen, giving rise to sulfur dioxide gas. Right, sulfur dioxide gas will be originated. Nitrogen is a non-metal. It is a kind of inert gas, nitrogen triple bond. It is the biatomic molecule. Upon reacting with oxygen gas, giving rise to the nitric oxide. Nitric oxide gas will be evolved upon oxidation of this nitrogen gas. Whenever you are taking carbon as a solid, you may take carbon in the form of graphite, in the form of coke, in the form of coal. So many allotropic forms are available for the carbon. This carbon subjected to or reaction with oxygen, giving rise to carbon dioxide gas as the product. This is the way either metal upon oxygen reaction giving their metal oxides, non-metals upon reacting with the oxygen giving rise to non-metal oxides. Whatever the kind it might be, there is a provision to generate the oxide forms, right? Occurs in the various states. Whatever the product's generation may be either in the solid, liquid or gaseous, all phase conditions are possible for this. If you observe, tin may be taken in the liquid form upon reacting with the gaseous oxygen, giving rise to a solid oxide form. So even silicon taken in the solid, gaseous oxygen giving rise to a solid oxide. All the oxides generated for these metals are solids in nature. But whenever we are taking non-metal, there is a provision to originate the gaseous oxides. There is a possibility to generate either solid, liquid, or gaseous phase reactions for these kind of oxidation process. Now, now we are going to discuss about can we mention food digestion is the kind of oxidation process. Every day we are consuming food. Without food, it is not possible to survive, not possible to energize our body. It is a kind of fuel. Food is a kind of fuel for the healthy survival, so that food intake is required from time to time. Minimum 3 hours are required in order to digest the food. Whatever complicated food materials are subjected to a series of enzymatic reactions giving rise to a final energy. This is a continuous process carried in the different time intervals. We are supposed to consume the food and the digestion process is carried. Now, in terms of chemistry context, can we mention the digestion process of the food is said to be a oxidation? Yes, we can say it is breakdown of the food materials is called oxidation process, and that is called a cellular respiration. Just now we mentioned regarding this one, glucose is subjected to reaction with oxygen, giving rise to a carbon dioxide, water, and the 38 ATP molecules are generated adenosine triphosphate that is originated in the device called mitochondria, which is the powerhouse of the living organisms. Energy stored in the form of ATPs, right? Breakdown in the macromolecules, whatever this oxidation process we are discussing about during the digestion process, in the macromolecules like carbohydrates are there, fats are there, proteins are there. Whenever they break they were broken by means of oxidation process, complex carbohydrates now turned into a glucose, and the fats will be transformed into fatty acids and glycerols. Whenever proteins are broken, there is a formation of fundamental units called amino acids. This is the way you can clearly notice this is a complex protein you can observe. This protein is supposed to broken, that giving rise to polypeptides, somewhat simpler unit you can notice. That simpler unit again back converted into a helical species, and again we are supposed to make it a starting material called amino acid. This is the way whatever complex molecules we are taking into a food, into our through the dietary source we are consuming, they subjected to the process called oxidation and giving rise to a simpler molecule. Further, they subjected to oxidation giving rise to energy. Cellular respiration is a process where the oxidation is carried in the series of steps giving rise to adenosine triphosphate, and you can clearly notice this glucose upon oxidation giving carbon dioxide, water, and energy in the form of ATP. And cellular respiration is carried in various conditions. One is said to be a glycolysis, and perhaps a cycle will be there, and electron transport chain will be there. In all these conditions, there is a generation of ATPs are possible, and the generation of carbon dioxide is possible. All are not possible in the single organism based on the complexity of organism, based on the availability enzymes, based on the kind of species what we are choosing. This kind of life process are possible, said to be glycolysis, Krebs cycle, and electron transport chains are possible. This is the process about the glands of glycolysis. Initially, glucose molecules were taken, and glucose 6 phosphate will be originated by consuming phosphate species. Later on, fructose phosphate, this is a kind of isomerization we can notice, and glyceroldehyde 3 phosphate will be generated by, this is a kind of transformation by enzymatic action, and so many biological transformations are possible inside the living organisms, so that glyceroldehyde 3 phosphate will be possible. Later on, 2 phosphates are blended up so that it turned into a diphosphoglycerate PC3P. 1 comma 3 diphosphoglycerate will be generated, and now it can be transformed into 3 phosphoglycerate. 3 phosphoglycerate will be generated, where we are supposed to remove the water called a dehydration process, that giving rise to a phosphoenol pyruvate. Phosphoenol pyruvate will be originated, and the pyruvate final product will be pyruvate. In the glycolysis, the final product will be pyruvate, so that there is a origination of ATPs are possible. This is the way glycolysis is carried in a cytoplasm. Cytoplasm is the device where the process of glycolysis is carried. And next is said to be Krebs cycle. Krebs cycle is also denoted as a citric acid cycle alternatively, where citrate can be taken, coenzymes are blended up, glucose and fatty acids upon treating with acetyl coenzyme A. So that citrate will be generated. This citrate will be treated with water, and that citrate will be isomerized, giving rise to isocitrate, where reducing agent will be mixed up so that ketoglutarate will be generated, and succinyl coenzyme A is the next step by enzymatic action, and letter and succinate. Succinyl coenzyme A next turned into succinate by the removal of this coenzyme A part, and succinate is able to bind up with the FAD so that reduction is carried over, and that will be isomerized into fumarate. That fumarate is added with water so that fumarase enzyme is also the key role in order to morpholize for fumarate into a malate. Malate will be added with the NAD. NAD will be reduced. That means abstracting hydrogen over there, and NADH will be generated in the presence of enzyme called malate dehydrogenase. Oxaloacetate will be the part over there. During this process, again, there is a provision to generate ATPase. This is called a Krebs cycle. Krebs cycle is meant for the generation of ATPs and giving rise to this energy by consuming this glucose and fatty acids. Let's go with another technology called electron transport chain. Electron transport chain, where cytoplasm, it is carried at the cytoplasm. It is the outer membrane, and in this outer membrane, inner membrane, intermediate space will be there. There itself, NADH will participate in the reaction and giving rise to the electrons, and that in turn converted into NAD plus. Later, electrons released will be transported, being it is a kind of electron transport chain. It will be transported over there, and finally there is the generation of ATP. ATP formation is possible in the presence of enzyme called ATP synthase, where ADP will be reacted with this phosphate, and acid catalyzed reaction is carried over, and ADP now transformed into ATP. ADP stands for adenosine diphosphate, and here the formation of adenosine triphosphate is possible. And the entire process carried at the powerhouse called mitochondria. And this is the kind of cellular respiration where the respiration process carried by this lung system. And here we have a trachea, and through which exchange of the gases are possible, and the lungs are able to contract and elongate in order to circulate the air over there. Being the circulation of air carried the entire lung system, there the circulation of blood is also possible, which able to collect the oxygenated air. Oxygen will be collected by this blood, and that will be transported through the cardiovascular system into entire human organs. This is the process carried where the combustion of the food process is taken by this oxidation natural process. And let me thank you for the entire session, which is most valuable in nature in terms of synthetic organic chemistry, and which was taken by the natural oxidating agent oxygen. And the session conducted by Dr. Kavita Kottireddy Kota. And I'm very much glad for this session, and it is said to be more informative in nature. Thank you very much for your patient listening. Thank you, one and all.